Hello and welcome to the Kairos Academy. Today's topic will be blockchain consensus mechanisms. In a centralized system, one entity has complete control and can make changes, but when it comes to a decentralized system, the game changes. For example, if we are dealing with a distributed database like blockchain, one would ask, how do we come to a consensus on what entries are added? This was a demanding obstacle to overcome in an atmosphere where people don't necessarily trust one another. And it ended up being the most critical development that paved the way for blockchains. This is why consensus algorithms are so essential for the operations of cryptocurrencies and blockchain. In simpler terms, it is the technique used to validate transactions and add them to the blockchain. Basically, the consensus mechanism is a process where the different members or computers of a blockchain network come to a shared agreement on the information that is stored on the blockchain. The consensus process involves multiple nodes on the network verifying the proposed transaction or block against the network's rules and validation protocols. Once a consensus is reached, the verified transaction or block is added to the blockchain, and then the network proceeds to the next block. This is what makes blockchain technology so reliable and secure. There are many different types of consensus algorithms, also called consensus mechanisms. One of the earliest and most well-known consensus mechanism is proof of work. It was first introduced in the original Bitcoin white paper in 2008. The way it works is that the nodes in the network, called miners, compete to solve a complex mathematical problem. In case you're wondering, miners are computers validating cryptocurrency transactions on a blockchain network and adding them to a distributed ledger to locate them. We have a section in our cryptocurrency course that tells you more about mining and how you can mine cryptocurrency. The first miner to solve the problem gets to add the next block to the chain and earns a reward for doing so. Proof of work is considered the godfather of blockchain consensus mechanisms. At first, it was implemented in Bitcoin, but the actual concept has been around for some time. Another type of consensus mechanism is called proof of stake. It was developed as an alternative to proof of work. It aims to address some of the issues associated with proof of work, such as high energy consumption. The reason why proof of work uses a lot of computational power is because it relies on mining to validate transactions. As we saw in the mining process, nodes on the network compete to solve complex mathematical problems to validate transactions. These problems are designed to be challenging and require many calculations to solve in order to ensure that the blockchain network is secure and resistant to attacks. It makes it computationally expensive and time-consuming for any malicious actor to try to manipulate or corrupt the blockchain data. But this is also why, by being very computationally intensive and energy-consuming, the mining process consumes a lot of electricity. Enter proof of stake. Instead of using computational power, proof of stake requires validators to hold and stake a certain amount of the cryptocurrency used in the blockchain network, such as Ether for the Ethereum network. The cryptocurrency staked acts as a form of collateral. The more cryptocurrency a node stakes, the greater its chances of being selected to create the next block. This process is similar to a group of people voting on a leader. The person with the most votes is elected as leader. In September 2022, Ethereum completed its long-awaited transition from proof of work to proof of stake. According to the Ethereum Foundation, the transition to proof of stake has resulted in a 99.95% reduction in Ethereum's energy consumption. Two other consensus mechanisms we can mention are delegated proof of stake and proof of history. Delegated proof of stake is similar to proof of stake, but instead of all validators participating in the consensus process, a small number of delegates are chosen to validate transactions and add new blocks to the blockchain network. This makes the consensus process faster and more energy efficient. Proof of history is a consensus mechanism that was developed by Solana, a high-performance blockchain platform. Proof of history is designed to provide a secure and efficient way to establish a linear order of transactions within a blockchain network. In proof of history, a series of timestamps are generated and added to a ledger using a cryptographic hash function. These timestamps serve as a proof of the order in which transactions occurred. They can be used as a reference for other nodes on the network to validate transactions without having to perform complex and resource-intensive computations. This makes proof of history more energy efficient than proof of work. In terms of which is better, it depends on the specific use case and the goals of the blockchain. Proof of work is considered to be more secure and decentralized, while proof of stake is more energy efficient and scalable. Proof of work is now mostly used by Bitcoin blockchain network. Many blockchains use proof of stake or delegated proof of stake. Keep in mind that no matter what consensus mechanism is used, the goal is always the same: to make sure that the state of the blockchain is accurate and that everyone in the network agrees on it. Today, consensus algorithms not only back up digital money systems, but also enable developers to deploy code on a decentralized network. Thank you for watching, and we hope this has offered you a better understanding of blockchain consensus mechanisms. See you in the next video.